of the algorithm is Vinay itself. And what you are doing within the if condition, what are you calling? What are you calling within the if condition? The algorithm itself, Vinay algorithm you are calling. So the time you call it, it will bring you into infinite loop. Means before calling this algorithm, somewhere here, you should provide a provision, or somewhere while writing the condition, you should provide a provision for coming out of this infinite time calling this algorithm itself. So this will be the basic nature of an algorithm.
Sir.
हाँ बोलिए.
Sir, are you sharing your screen?
No, I forgot it. Yeah, so this was here. This is the example where you are calling the algorithm. You are calling the algorithm. Algorithm name is Vinay, and you are calling the algorithm itself Vinay. So it will bring you into infinite loop. It means before this Vinay, before calling this algorithm Vinay, here just before its statement, you should provide some provision for coming out of infinite loop, or within the condition here, if condition mentioned. Within the condition, you should specify certain specific conditions when the algorithm should be called. Otherwise, you should go for the execution of the else statement. So this example is visible to you on the screen?
Yes, sir.
Yes, sir.
And as I suggested, this algorithm, it is bringing you into, since it is recursive algorithm, and I have not provided any provision here, just structure I have given, so it will bring you into infinite loop. So you should provide provision. Now we will see the performance analysis of algorithms. Whenever you are analyzing the performance of any algorithm, so two things you need to do, either on the basis of space complexity, you analyze the performance of algorithm, or on the basis of time complexity, you should analyze the performance of algorithm. So space complexity based performance analysis of an algorithm, what will you say? Suppose you want to write a program for finding real roots of a quadratic equation. You have to write a program for finding the real roots of a quadratic equation. Then what will be the rule? What will be the role of space complexity here? Two students have written programs, or maybe 4 students have written 4 different programs. So you have to know, you have to use this space complexity method, and you have to find that which algorithm or whose algorithm is the best one. So if you are using space complexity method, how will you know?
So the space consumption should be less.
So 4 students have written programs, 4 programs, and amount of space. So amount of space means what?
Sir, big O of 1 n square.
Big O की बात ही नहीं हुई है. Amount of space taken by the program while you are storing it on the hard disk. Amount of space taken by the program while you are storing it on the hard disk. Suppose program 1, program 2, program 3, program 4. It is X, Y, Z, W. Where X is greater than Y is greater than Z is greater than W. So whose program has taken maximum space on the disk?
X, sir.
X means first program.
Yes, sir.
So this can be amount of space taken by the program on the hard disk. And second thing is amount of space taken by the program at runtime. runtime space. So these two things you will take in terms of space complexity. What different things will you take in terms of space complexity? Avinav Kumar, बोलिए तो. Avinav Kumar.
Yes.
What different things will you take into considerations for space complexity? क्या क्लास में है कि क्लास से बाहर है? आदित्य या तुल्या? चलिए अभिनव कुमार ने भी फीस दिया नहीं है, इसीलिए मन से नहीं पढ़ रहे हैं. आदित्य या तुल्या, what different things will you take into consideration for space complexity?
So the lesser space that a program will occupy will give better.
So space means what space? Is it space on the hard disk, or it is runtime space, or it is both?
Both.
Both. So remember, when we talk about space complexity, these two types of spaces we are talking about. Amount of space taken by the program on the hard disk, first thing. And second thing is amount of space taken by the program while its execution. And Aditi, whose program will you say that it is best? The program which is taking more space on the hard disk, more space in the memory, or the program which is taking less space on the hard disk and less space in the memory? Which program will you say the best?
The one which takes less space.
Less space on the hard disk and in the memory, that would be considered as the most efficient. And being programmer, being software engineer, your objective will be to write a program that is taking minimum space on the hard disk and minimum space. It is taking minimum space at runtime. So that is it clear, everyone? Abhinav Kumar, is it clear now to you?
Yes, sir. Yes.
So that is, भाई अगर क्लास में आपको समझ में नहीं आता है तो हमारे पढ़ाने का कोई मतलब नहीं है. उससे अच्छा है कि मैं ना पढ़ाऊं, कह दूं कि पढ़ लो यार. और क्लास में आप 15 मिनट्स टाइम दें और फिर भी कुछ नहीं समझ में आए तो भाई उसमें मैं मानता हूं कि फिर मैं किस बात का पढ़ा रहा हूं. इसीलिए क्लास में 50 मिनट, if you are spending 15 minutes of time, something you should understand, something you should be able to understand. कुछ समझ में आए, कुछ लगे कि हाँ आज कुछ लेके गया. So this is about space complexity. So whenever you are analyzing the performance of any algorithm, or whenever you are comparing the performance of two or more algorithms, so you can use the space complexity method, as I mentioned. And remember, being software engineer, your objective is to use minimum space on the hard disk. And your algorithm should take minimum space in the memory. Minimum space in the memory. That is the space complexity. Any confusion to any one of you about space complexity? Koi confusion?
No, sir.
No, sir.
No, sir. नहीं होगा ये. अनमोल अमृत, any confusion?
No, sir.
चलिए. Now let's move to the next topic. That is the first one is the space complexity and second one is the time complexity. So you see here, time is mentioned here. So time complexity means this is CP, time complexity of a program, or time complexity of an algorithm TA equal to CA plus RA, where A is representing algorithm. Time complexity of an algorithm, TA equals to CA plus RA. This is equation number 1. In this equation, what is CA? CA is the time. Yes, CA is the compiled time, amount of time taken by the algorithm at the time of its compilation, or amount of time taken by the program at the time of its compilation. And what is RA?
Runtime, sir.
RA is the amount of time taken by the program or amount of time taken by the algorithm at the time of its execution time or runtime. And if you add them together, so that will be the time complexity. So how will you define time complexity? How will you define time complexity of an algorithm? कोई एक डिफाइन कर दे, ये आनंद राज पेरेंट्स ने राज नाम रखा है जिससे भाई बिल्कुल राजा की तरह जीवन कटे। आनंद राज, आज ये गायब है, चले गए वो लेने। पेरेंट्स ने कहा अभी जो है आओ जरा सब्जी लेके आओ, क्या पढ़ाई लिखाई करोगे? पढ़ाई लिखाई से थोड़ी कुछ मिलना है। अंकेश कुमार,
Yes, sir.
how will you define time complexity? आपके दोस्त आनंद राज, he has gone for purchasing vegetable. पेरेंट्स ने भैया देखो फीस दे दिया है, आप क्लास तो पास हो ही जाओगे, और नॉलेज लेके क्या करोगे? नॉलेज लेके कोई स्टूडेंट गया है आज तक? या नॉलेज लेके कोई नौकरी पाया है? नौकरी तो जुगाड़ से पाएंगे। हाँ चलिए आप बताइए अंकेश कुमार।
So the program which will take less run time and compile
First
time.
to define what is time complexity of an algorithm. What is time complexity of an algorithm?
So the algorithm which will take less time to.
Guru, I am not talking about the algorithm which is taking less time, which is taking more time. What is time complexity? Abhijit, Vijay, you have smiling face. So what is time complexity? ये देखो, देख कितने लोग हैंड रेज किए हुए हैं। चलिए अमीसा अरुंजय, what is time complexity?
Sir, the amount of time an algorithm takes to complete its execution.
The amount of time taken by the algorithm while its compilation and while its execution, or amount of time taken by a program for its compilation and execution will be called as the compilation time. And mathematical, thank you, bring your hands down everyone. And mathematical formula is this one. This is TA equal to CA plus RA, or TP equal to CP plus RP. Now we have come to the, how will you compare two algorithms in terms of time complexity? So if you are comparing two algorithms in terms of its time complexity, then the algorithm which takes less time means the algorithm for which compile time plus run time is minimum. That algorithm will be considered as the best one. If 4 students have written programs, then the student whose program is taking minimum time in its compilation and execution, taking minimum time in compilation plus execution, that program will be considered as the best program. So this is general term definition. But what happens that you see here problem. 4 students have been given to 4 students. So you have 2 options. Either all the 4 students, they should run their program on the same machine. Yes or no? All the 4 students, they are compiling their program exactly same machine. They are executing their programs exactly on the same machine. Then you can say that the student whose program is taking minimum time, compilation plus runtime, that is the best algorithm. That student's algorithm is the best one. But it is always not happening. Every student has different independent computers. And student 1 is compiling the program on his computer. Student 2 is compiling the program on his computer. Student 3 is compiling the program on his computer. Student 4 is compiling the program on his computer. And each one student's computer's specification is different. Every student's computer specification means hard disk, CPU, RAM, they have different size. Then what will you say? Whose program is best one? Reply me. This time raise your hands. 4 students are there. They are executing the same program on their 4 computers independently. Each one of these 4 computers is in terms of hard disk, RAM, and CPU speed. Now, whose program is best? Whose algorithm is best one? What will you do? Will you use? Yeah, boliye.
Sir, your video was paused. Can you repeat that line?
My video was not paused.
Maybe there is a network issue
lag.
from my. Yes, sir.
So 4 students are there, and each student has independent computer, and they are running the same program on their computers, and each student's computer specification is different. They are running same program, and you have to decide that whose program is the best one, whose algorithm is best one. Then will you use time complexity or not? If not time complexity, then what methods should you use? If you say space complexity, then I will say that almost exactly same space they are taking. Same space on the hard disk they are taking. Almost similar space, same space at runtime they are taking. Then how will you analyze their programs, their algorithms? Now question is clear to everyone?
Yes.
The time taken by every program is different.
Yeah, they are using different machine. Program 1 machine is different from second one in terms of specification of CPU, in terms of speed of CPU, in terms of hard disk, in terms of RAM, in terms of CPU speed. Everyone is using a different CPU. And now they say that, sir, my program is taking minimum time. And the second one is saying, mine is taking minimum time. Third is taking, no, mine is taking minimum time. And fourth one is saying that, sir, you see, everyone's CPU speed is different. And my CPU is slowest one. And in my being slowest CPU, mine is taking the second minimum time. So mine is the best one. Mine is the best one. So what should I do? कोई हैंड रेज किया है अरुंधति मुखर्जी बोलिए
Sir, we will consider the computer with the worst specification and best time complexity.
Best time is what?
I mean the slowest computer but which is giving second or maybe first or second best time.
So slowest computer and second position holder, you say that his is the best algorithm.
Yes, sir, I guess.
So whosoever computer
Sir.
is giving the first minimum time, we will say that sir is a biased mind. And if once it is proved that your faculty member is biased one, after that no one will listen to the faculty member. बेईमान जो है फिर चिल्लाना शुरू कर देंगे आप. हाँ, हर्ष कुमार, हर्ष गोविंद.
Sir, the algorithm which take almost equal time in all the system, that algorithm will be the best algorithm.
Their system is taking, if you sum the compile time and run time, everyone is getting a different number. Then
So then the algorithm which
then
take
whose
less
algorithm is
time.
best? Then the algorithm which is taking less time, you will say that that algorithm is best one. But the algorithm that is taking smallest time, other students, they are saying that sir, his CPU is very fast one. His CPU speed is 5.88 gigahertz, and our CPU speed it is just 4 gigahertz.
Yes, sir.
अब क्या करेंगे? So can you use the time complexity method?
No,
Or
sir.
can you use the
yes.
space complexity method? Space, they are taking same space. Yes or no?
No, sir.
I
यहाँ
will
पे
say
बहुत difficult
no.
हो जाएगा.
Yes. So I will say here, you cannot use this physical time-based system. So in that situation, the time complexity method or space complexity method, it will not work. It means that there you will use some mathematical notations. If dispute occurs, then you will say that, okay, come to convert your algorithm in the form of mathematical equation. क्या बोलेंगे आप, हर्ष गोविंद? What will you say? Everyone's computer is different. Everyone's computer is different. Speed is different. They are running the same program and they are getting different time. So on the basis of time, if you evaluate the performance, it will be an incorrect answer. So you will say that no, time constant will not be the factor. You will say that I will convert your algorithm in the form of mathematical equation. And that equation will be represented in the form of some notations. And then we will see those equations will be analyzed. And on the basis of analyzing the equations, I will declare that whose algorithm is best one. So here in this situation, two things will you do. First thing, convert the algorithm in the form of mathematical equation. First thing, what will you do, Amisha?
So we will convert the algorithm to
in
some
the form of mathematical equation.
Yes, sir.
Maths में लेके आइए in the form of equation. So all the 4 students algorithms, you convert it in the form of mathematical equations. So you will get 4 equations. Equation 1 for student 1, equation 2 for student 2, equation 3 for student 3, equation 4 for student 4. And then convert these equations in the form of some standard notations. And after that you declare, suppose you converted then in the form of notations, then what happened? Now listen my next one. You converted program 1, program 2, program 3, program 4 into mathematical equation. And you found that for program 1, mathematical equation is n square plus c. For program 2, the mathematical equation is n plus c. C is constant. For program 3, it is n cube plus c. I'm repeating again. For program 1, it is n square plus c time. For program 2, it is n plus c time, where c is constant. And for program 3, it is n cube plus c. And for program 4, it is n log n plus c. I'm writing here on the screen. Let me share the screen. Did I share the screen? Yeah. I'm writing here on the screen. Just wait, kariye. Thoda dekhe. Let us see that who is able to reply. First program is, this is n square. Time taken by first program, it is n square. Time taken by second program, it is n time. Time taken by third program, it is n cube. And time taken by fourth program, fourth student, it is n into log n. So see, this is program 1. Program 1. This is time of program 1 when you converted it into mathematical equation. This is program 2. This one is program 3. And this one is program 4 when you converted program 4 into mathematical equation. So screen is visible, clearly visible
Yes,
to
sir.
everyone. Now you tell that whose program is best. Raise your hands. How many of you can reply? Raise your hands. Very good. Namrata Sharma, you try. Program 1 is, which is the best program? Whose algorithm was best one?
No,
Huh?
sir, program 2.
Program 2 is the best one.
Yes, sir.
So let me verify it from somebody else. Sachin Verma, you verify it. Whose program is best one?
Program 2 is the best.
So program 2 is best one. I am marking it as a red color. I hope all of you agree that program 2 is the best one. The people who raise
Yes,
hand,
sir.
No, sir.
कौन एग्री नहीं
Yes.
करता है? हाँ, सामने आइए जो एग्री नहीं करता, कोई बात नहीं, हो सकता है आप ही सही हो, हम गलत हो.
Sir, I am saying n log n, like program.
And log.
Yes, sir. N log n will be the answer.
चलिए, so what's your name, please?
Abhijit, sir.
अभी पूरा नाम बताओ.
Abhijit Vishwakarma.
अभिजीत विश्वकर्मा जी.
Yes, sir.
आज विश्वकर्मा जयंती नहीं है, नहीं तो आपको बधाई दे देता. Let's go for green color. अभिजीत विश्वकर्मा has gone for program 4 and log n. अब आइए, एक क्लास थोड़ा सा इंटरेस्टिंग जा रहा है. How many of you are with Abhijit Vishwakarma? All of you bring your hands down. How many of you are with Abhijit Vishwakarma? Raise your hands. जो लोग अभिजीत विश्वकर्मा के साथ हैं, चलिए. हर्षवर्धन, you are with Abhijit Vishwakarma?
Yes, sir.
Very good. Abhijit Vishwakarma and you see, I am distributing money free of cost. पैसे दे रहे हैं हम. Abhijit Vishwakarma and Harshvardhan, they are saying that, sir, give us n log n rupees. They have gone for fourth one. They say that, sir, give us n log n rupees. And others what they say that, sir, give us n rupees. Give us n rupees. किसको ज्यादा पैसे मिलेगा, किसको कम पैसा मिलेगा? n वाले को ज्यादा पैसा मिलेगा कि n log n वाले को ज्यादा पैसा मिलेगा?
Sir, n वाले को ज्यादा मिलेगा.
n वाले को ज्यादा मिलेगा ना? n log n वाले को कम मिलेगा.
Yes.
No, sir, n log n वाले पे ज्यादा मिलेगा.
ज्यादा मिलेगा means
Yes, sir.
n log n, the algorithm which is taking n log n time, that is taking more time.
Yes,
and
sir.
the algorithm that is taking only n time, that is taking less time. So if two algorithms are written, so which algorithm is the best one? The algorithm taking more time or the algorithm taking less time? Which algorithm is best
Less
one?
time.
Less time.
The algorithm which is taking less time. Is it like if I say n is 100? So if n is 100, so you see the value of program 2. Value of program 2 will be 100. And value of program 4 will be how much? N log
200.
What is
100.
the base of log, sir?
You can say base 10, you can assume.
Base 10, sir.
200, sir.
The 200.
Yeah. So n log n will be how much?
The
200.
200.
200.
So program 2 is taking 100 unit of time. And program 4 is taking 200 unit of time. So who is taking the smallest amount of time? Program 2 or program 4?
Program 2, sir.
Harshvardhan ji.
2, sir.
Harshvardhan. 2
Yes,
or
sir.
4?
2, sir.
So Harshvardhan thought that sir is going to give us money, so let's go for taking more money. So it says definitely here program 2 is taking minimum time, and what I said, you are comparing 4 programs, you are comparing 4 algorithms. So which algorithm will be considered as best one? The algorithm which is taking maximum time or the algorithm which is taking minimum time?
Minimum
Which
time.
algorithm is
Minimum.
best
Program
one?
2.
So now
Program 2.
all of you agree that program 2 is taking the minimum time. It means that as far as best algorithm is concerned, so the algorithm corresponding to program 2 is the best one. This is the best algorithm. All of you understood what I said?
Yes, sir.
Yes,
Yes,
So
sir.
what was my
Yes,
basic question? 4 programs were there, and all the 4 programs, they were executed on 4 different machines. And the students started quarreling, and they started blaming that, sir, you are a biased man. So what I did, Abhinav Kumar, क्या किया मैंने? What
Sir,
did I
time
do?
complexity.
So what did I do? मैंने क्या किया? उनका टाइम कंप्यूट करके बता दिया कि मैथमेटिकल इक्वेशन में ले आया.
So
What did I do?
convert करके
I
mathematical.
converted their programs in the form of mathematical equations. And when I converted their programs in the form of mathematical equation, then here it does not matter that on what machine, on which machine they executed the program. Whose machine was having best specification? Whose machine was having the worst CPU? Does it matter now in form of mathematical equation? Aman, yes or no? No, does not matter. Because you converted them in the form of mathematical formula, mathematical equation. And now on the basis of mathematical equation, now you have come to conclusion, and what you said? You said that this is program 2. It is taking minimum time in terms of mathematical representation. So program 2 is the best. हाँ बोलिए.
Sir, what if when we will take n less than 10, then the log n one answer is correct?
Repeat your question, please.
Sir, I was telling then what if we will take n less than 10, like
Yeah.
8, 9, and 4, then,
So
then the answer is...
Initially, Amya, Subhas, anyone who wants to reply? Chaliye, this is second lecture, so let me ask that. We are
Yes,
revising, we are going for revision. Anyone
We
who wants to
actually
reply,
take-
or Amya is correct?
Sir, we calculate complexity for larger inputs. No? That's why.
Absolutely. So you, Amya, Abhijit Biswakarma is correct. If you take n equals to 1, so you will see that program 4 is taking minimum time. Clear?
Yes, sir.
Log 1 is 0. So keep on increasing the value of n more. So then you take n equals to 2. Then you will say that program 1 is taking 4 unit time, program 2 is taking 2 unit time, program 3 is taking 8 unit of time, and program 4 is taking this is 2 into 0.30109. But what you have to do, you keep on increasing the value of n now. Clear, Amya? And for any value of n greater than equal to 100. Please listen my sentence. For any value of n greater than equal to 100, the minimum time taken will be only by program 2. You take value of n equal to 100, you take n equal to 200, n equal to 300, n equal to 400, n 1000, n 5000, n 10,000, n 1 million, n 10 million, n is 1 billion. So for any value of n greater than equal to 100, what is happening? Who is taking minimum time? Or for any value of n greater than equal to 10 also you can take.
Yes, sir.
For any value of n greater than equal to 10, who is taking minimum time?
Program 2.
Program 2 is taking minimum time. This is why you will say that the best algorithm is program 2. Some cases less than 10, there are very few cases. So those cases you may ignore. But huge number of cases are existing, means for any value of n greater than equal to 10. Means from n equal to 10 to n infinity, n equal to infinity. For all of these values, program 2 is taking the minimum space. This is why you will say that program 2 is the best algorithm. Now is it clear, Amya?
Yes, sir.
Your question, this was good one. Or later you will see some mathematical computations on the basis of whatever we discussed just now. Now you see, so their time complexity you are not able to use. So it means that here what I used, I have gone for, instead of saying notations, I will say I have gone for notation based representations. I will discuss it on later. But if time complexity is not able to find the analyze at which is the best program, space complexity is not able to analyze at which is the best program or best algorithm, then you will go for some mathematical notation based analysis of the algorithm. Now, last thing, if you are analyzing the performance of any algorithm, how many cases will be existing? 3 cases. Either best case analysis or worst case analysis or average case analysis. So these 3 analyses will be there. Best case analysis, worst case analysis, and average case analysis. So next we will take the example of insertion sort, and we will see that in the best case analysis, what is the behavior of insertion sort. In the average case analysis, what is the behavior of insertion sort. And in worst case analysis, in worst situation, what is the behavior of insertion sort. So these 3 things we will discuss in the next lecture. So what I suggest to you all that ये note कर लीजिए, insertion sort पढ़ के आइए. Please read the topic insertion sort, and then you come to the next class. Now I have downloaded your attendance. ये next class I will have with you on tomorrow. So this one is your attendance for today. This one is your attendance for today. I have downloaded it. Screen is visible. So now you come to the next class tomorrow at 2:30, and please prepare. क्या prepare करके आएंगे? What will you prepare?
Insertion sort.
Insertion sort.
Yeah, your Aman Pandey ji. Aman Pandey. Insertion sort, you prepare it and analyze it, and then come to the class. I will like to know that what is the best case of insertion sort, what is the average case of insertion sort, and what is the worst case of insertion sort. Any confusion, any doubt in today's lecture, whatever things I discussed, you ask. Amya, your one question was very good for today. So I will like that if others are also asking questions. Any other question?
No, sir.
No. So thank you very much for today's class. Now let's meet on tomorrow at 2:30 in the lecture class.
Thank you, sir.
Thanks to all.
Thank you, sir.
Thank you, sir.